Well, in this chapter, we would like to introduce the concept of numeric and geometric patterns. Now, this is a fairly new chapter, but it's not about something which is completely new. Now, we meet these things of patterns basically every day in our life. And because of that, we will go through this discussion here to extend what these patterns are. Now, when you look at some of these pictures that I've shared with you here, these are pictures of squares. They're very much like tiles that have been placed somewhere on the ground. When you look at it carefully, there is how they have been arranged. They have some type of a pattern, okay? Well, let's look at the next example. Here you have plates that have been arranged, one placed over the other. And also when you look at it carefully, there is how they have been placed. And something slightly above it, it's like, the seat that you would have in a stadium. When you look at a big stadium, which is supposed to host thousands of spectators, you would want to ask yourself, how do they come with a design of how many people will fit inside here? That is about pattern. How the numbers will be calculated, how seats will be arranged so that they take the smallest space available. That requires knowledge of pattern. Pattern does not only appear in what we do. Pattern also occurs naturally. When you look at this next picture, this is a plant, and this plant grows in such a way that the pattern is in fact so nice looking that you would really want to have it in your compound. That is just one example. Look at this then. So this is another picture of a bird with feathers that forms a very nice pattern of colors. You can see this for yourself. And also here, you see chairs that have been arranged in some pattern. And for example, each have got, the same number. Then after that, you also have the same number of chairs. And also here you have the same number of chairs. How do we deal with patterns in a mathematics class? Now that's the question to deal with. How do we handle mathematics pattern? How do we handle pattern in the mathematics class? Well, let's look at this. Here, we are given that on the left-hand side are numbers. And to get to the right-hand side, there is a processing plant. Before you reach the right-hand side, the value you carried must be multiplied with 6 so that you get what you have on the right-hand side. So the question is, how about if the number is different or the value you're carrying is different? What would it be? Well, the pattern is still the same. The pattern here is defined by a times 6 so that you get there. So that would mean if you have a value of 1, okay? So here we are talking of pattern of 6. Okay, pattern of what? Rather times 6. So if you have a 1, okay, for the first case, for example, if you have a 1, you have to times that, or you have to multiply it with 6 so that you get what? So that you get to the right-hand side. So here you got the 1 through this rule here, which requires us to multiply each of this value by 6. Then we get what? Then we get that. Now, the next thing is, if we have, for example, another value, for example, this time we have a value of 2. How do we reach the other side? Well, to reach the other side of the processing plant, you have to follow the rule of what? Of multiplying it by 6. What do you get that side? 12. Now, for the next quantity, we have what? We have a 3. Now, after a 3, we will have to follow the rule which requires us to multiply it by 6. What do we get that side? Well, what we get that side is 18. Now, the next thing here would obviously be, you see, also here there is a pattern already you can see for yourself. There is 1, there is 2, there is 3, here must be 4. Okay? Because when you multiply 4 with 6, you still get 24. And so in our next, in the next step, we have the number 4, which is used to do what? Which is used to multiply 6, so that we get 24. Now in the next step, that is part E now, in the next step, we have what? We have 5. Now this 5 is used to multiply 6, so that we get 30. Then in the next step, we have what? We have the number, well, let's first put the number is 6 this time. Well, how do we reach that side? Well, even if it is 6, when we multiply it with another 6, what we get that side must be 36. You see? Then in the next step, then we have one more quantity, which in this case is 7. This 7 must go through the process of multiplying with 6 or times 6. Well, what do we get for this? We get a 42. Now, notice that there is some rule that we follow, and this rule is the same for all the quantities coming in. The quantities can have different values. What is coming out will not be the same quantity. It will be different values, but the rule is the same. And what is the rule? The rule is times 6. So now what are we talking about? Well, we are talking about getting from one point to the other point through a process, through some rules. Now, in this chapter specifically, you will learn to recognize, to create, to describe, to extend, and to make generalizations about numeric and geometric patterns. Okay, so once again, you will learn how to create, you will learn how to recognize, you will learn how to describe, extend, and make general or generalizations about numeric and geometric patterns. Now, pattern allows us to make predictions. We can predict what is going to come based on the rule we already know. And that is now where we say patterns allow us to make predictions. Now, you will also work with the different representations of patterns, such as flow diagrams and tables. We will see all that in this chapter. Okay? Now, notice that a list, okay? A list of numbers which forms a pattern is called a sequence. Okay? A list of number which forms a pattern is called a sequence. For example, this number here, these numbers that we have got, the 6, the 12, the 18, the 24, the 30, the 36, and this 42. This list of numbers which came to be after following this rule or this pattern of multiplying each number entering by 6. This list of numbers, okay, which forms pattern is what we call a sequence. Or in a rather precise way, the thing for you to remember is a list of numbers which form a pattern is called a sequence. Each number in a sequence is called a term of the sequence. And the first number is the first term. So very much like for this quantity we are dealing with, well, let's just create it like this. We had 6, okay? We had 6, then we had 12, then we had 18, then we had 24, then we had 30, then we had 36, then we had 42. So these numbers here that we are dealing with, the 6, the 12, this other one, these numbers that forms a pattern is called a sequence. The other thing is each number in a sequence is called a term. And so 6 is called the first term, 12 is called the second term, 18 is called the third term, 24 is called the fourth term, 30 is called the fifth term, 36 is called the sixth term, and 42 is called the seventh term. Okay, so these ones are called the terms of the what? The terms of the sequence. It's very important that you get these definitions right. Okay, now sometimes we are required to form this pattern. Rather, sometimes we are required to find some additional quantities that would come out of a pattern. Okay, remember we have already said numbers or list of numbers that forms pattern is called what? List of numbers that form patterns is called a sequence. Now, sometimes we are required to generate a pattern, or sometimes we are required to use a sequence to find the missing numbers, like which are the other numbers remaining. For example, here, what would be the next number? You see, what would be the next number? We have seen that they have been multiplying by 6, by 6, by 6. So what would be the next number? Now, investigating which number should come requires us to identify the type of rule which has been used. Okay? We need to know the rule which has been used. And how do we determine that? Well, for the most part, you have to look for the first term. Then you also look at the second term. Now, if the first term is less than the second term, then two things happened. Either a number was added to the first term, or a number was multiplied by the first term. Okay? Either a number was added to the first term, or the number was multiplied to the first term, if the second term is what? Is bigger than the first term. For example, from 6 to get to 12, what do? We have to add 6. Then we get the second term. Now, the other thing is, from 12, which is the second term, to get to the next term, which is 18, what do? We could add a 6. And we get what? 18. Now, if we have got 18, to get to the next term, we have to add a 6, so that we get a 24. So either something has been added to the first term, or the first term was multiplied by the other quantity. So for example, well, if we take this sequence and we try to check with the second rule, well, we want to find out if we don't want to use the method of adding, can we get something else? Well, let's see what comes out. Now, what comes out is from 6, if we want to get to 12, we could multiply 6 by what? We could multiply 6 by 2. But then what do we get? 12. Well, if we move to the next, from 12, how do we get to 18? Now, notice the multiplication becomes a little bit tricky there. Okay? By multiplication, that would disturb us. Instead, if you are using the method of multiplication, then you have to be very careful. Like for this question, you would consider multiplying 6 with a 3. What would that be? Well, that would be 18. Then for the next term, you would consider multiplying 6 with what? With a 4. And what would that be? That would be a 24. So yes, addition appears to be quite obvious or a little bit easy to deal with when we are talking of, you know, the rule to get to a sequence. Like here, we could say, well, each of this term is having 6 added to it. And obviously, that would work. Or we could say the first term is being multiplied by 6. Rather, we have to multiply the first term by 1, then by 2, then by 3, then by 4, and we still get there. Okay, let's just go right away into the first activity which we have been given. Now, what's the first activity here? Well, the first activity here is that we do what? Is that we write down the next 3 terms. We are supposed to write down the next 3 terms in each of the what? In each of the sequences below. So now, how do we handle this? Well, we will carry on with our discussion that we already started. And our discussion had reached the level of, you know, generating or identifying or finding the rule that we should use. Okay? The rule that we need to do what? That we need to use. And we have been given here some activities. The first activity that we have been given is called sequence A. So let's put it down, sequence A. So now for this activity called sequence A, we have been given 2, 5, 8, 11, 14, 17, 20, 23. This is what we have been given. What are we supposed to do? We are supposed to write the next 3 numbers. We have to find the next 3 numbers. Okay. Yes, the next 3 numbers. How do we find the next 3 numbers? Well, to find the next 3 numbers, we first want to find the rule which was used to find the other numbers. Now, notice the first number is 2. Now, onto the first number, it looks like something was added because the next number is more than the what? The first number. The next number is 5. So it looks like they added 3 onto what? Onto 2 to get 5. Now let's see from 5. If we add 3, can we get the next number, which is 8? Also from 8, if we add 3, can we get the next number, which is 11? And also from 11, how can we get the next number by adding 3? That is to get 14. Well, we normally have to carry out this check. We have to check to be sure. Because if the first number is less than the second number, 2 things possibly happened. The first thing being, there is a number being added to the first number. Now, if some number is added to the first number. We now need to check, is that the same number which is added to the second number? Now, is that the same number added to the third number? I mean, if we add a number to the first number, if we add 3 to the first number, we will get a new number. Well, do we have to add the same number to this new number we got to get another new number? Then do we have to add the same number to the new number we got to get the other one? If you establish that the number being added is the same, then you could go ahead and just pick this last number and just add that constant number. Or we could take one step at a time and be like, well, onto 14, let's add 3. That will give us 17. And onto 17, let's add 3. And that would give us 20. And onto 20, let's add what? Let's add 3. That would give us 23. We also want to find out onto 23, when we add 3, what do we get? We get 26. And now, we also want to check onto 26, when we add 3, what do we get? We get 29. Well, the next 3 numbers are supposed to come after 23. So after 23, this would be the first number, 26. The second number would be 29, and the other number would be the number we get after adding a 3 onto what? Onto a 29. That would be what? A 32. So now our new sequence, okay? Sequence A would have a solution of what? It would have a solution of, well, right here, it would have a solution of the old number. Then we have onto 23, what do we have? We have 26. And onto 26, what do we have? Well, onto 26, we have 29. 29, yes. And onto 29, what do we have? Onto 29, we have a 32. Yes. After 29, we have a 32. So yes, this forms the sequence. And this is the solution to question 1. Now, the next question, which is question 2, is called sequence B. Now, we want to see what comes out of sequence B. So how do we get there? Well, notice that sequence B starts with 4. Then later, there is what? 5. This is sequence B. Then later, there is 8. Then later, there is what? 13. Then later, there is what? There is 20. Then after 20, we have 29. And after 29, we have a 40. Yeah. Now, how do we get the next 3 numbers for this sequence? That is the big question. How do we get the next 3 numbers? We check the first number. The first number is 4. Now, what we want to do here is, the next number is 5. So here is the question. What then happened? What then happened for us to move from 4 to go to 5? Now, notice that what happened here is that something was added to 4. The first number being 4. To get the second number, which is 5, we would like to think that onto 4, something was added. The next number being 8, we would like to think that onto 5, something was added. Because 5 is the next number, which comes after what? After 8. So what happened to that? Onto 5, something was added. And what is that? This time 3. Then we would like to think that onto 13, which comes after 8, something was added. Added to what? Something was added to 8. And so that would give us, well, that would give us a 5. Then again, one more time, let's look at 20. Now, we would like to think that from 13 to 20, something was added. Something was added onto 13. And what is that? That is a 7. Well, where are we going with this? All right, let's look at it critically. Now, critically, the first number is 4, the next number is 5, then followed by 8, then 13, then 20, then 29, then 40. What's that pattern? Now, notice that we don't have, obviously, a number which is uniform here. We have a 1, a 3, a 5. They're not the same. When you look at this other number, the previous number in sequence A, in sequence A, the number being added was the same, it was 3. But now, in sequence B, the number is not the same. So the question is, how do we deal with this type? Well, notice there is something in common. Here we have 1. Here we have 3. Here we have 5. The something in common is a 2. When you add a 2 to 1, you get a 3. When you add a 2 to 3, you get a 5. When you add a 2 to 5, you get a 7. Most likely, onto this number, which comes after 20, which is 29. Most likely, this 20, which would come first, what was added to it was this 7 plus 2. That then means the next number, which is 40, will come when we add on to 29. Okay, when we add on to 29, this sum here, which is 9, and to it we add 2. 2 is the pattern. Or simply, we can put it like this. We can say 7, then 2, then 2. Meaning, for the next number, because now we have reached 40, we are supposed to find what? The next numbers which comes after 40. So the next number which comes after 40 is what? Well, is 11 plus. Sorry, when we add this, we get 40. Now, the next number, we don't know. You see, we don't know this next number, but we know the formula to get there. The formula to get there is we write this number 40, and to it we add 7. Then we add 2, then we add 2, then we add 2. You see? You see the pattern coming out here? Yes, the pattern is coming out. It's spreading out. Well, what do we get that way? Now, we have to find this value. This is 47, 49, 51, 53. Yes, that is 53. Now, notice that we can check what we have got with the calculator so that we make sure everything is right. So with the calculator, we will have 40, we add 7 to 40, then we add 2, then 2, then 2. That will give us a 53. That will give us a 53, meaning here we have a 53. Now, how do we get the next? To get the next, we use the formula. The formula is we put 53, then onto 53, we then add, okay? What do we add? 7 for the first time. Then this time, how many 2s do we need? We need 4 2s. That is 2 for the first time, 2 for the second time, 2 for the third time, 2 for the fourth time. Notice the pattern is coming out, even in the way it is arranged here. And so what do we get for that? Well, with our calculator, we want to find out onto 53. When we add 7, then later 4 2s, that is 1 2 2 2 2, 4 2s, okay? 2 for the first time, then 2 for the second time, 2 for the third time, 2 for the third time. What do we get? 68. That is what we have got here. So we get here 68. See how it's coming? Well, the next thing we want to look at is the number which comes. Notice that we don't know that number, but we know the formula to get there. So what's the formula to get there? Well, the formula to get there is to have 68, and onto 68 we add 7. Then, well, we have how many 2s previously? 1 2 3 4. There are 4 2s, meaning this time we have to add 1 more 2 onto 4 2s, so that we have 5 2s. So this will give us 2 for the first time, 2 for the second time, 2 for the third time, 2 for the fourth time, 2 for the fifth time. See, the pattern is coming out. You see, there is how the 2 is appearing. And now, what's going to be the answer to this question? Well, the answer to this question will be onto 68, we add 2 5 times. So 2 for the first time, 2 for the second time, 2 for the third time, 2 for the fourth time, 2 for the fifth time. That should give us a value, which in this case is what? Well, it's showing me 78. Let me proof check. I will be having 68 plus 7, then plus 2 for the first time, 2 for the second time, 2 for the third time, 2 for the fourth time, 2 for the fifth time. That gives 85. So that gives us 85. Yes, 85. So that means for this pattern, which is right up here in sequence B, for this pattern in sequence B, we are going to add 3 numbers, and these 3 numbers are, the first being 53, the second being 68, the third being 85. This is how you would find out the patterns in sequence B. The next thing is what? Sequence C. So how do we handle the case of sequence C? Well, to find the value of sequence C, that is sequence C, sequence C has been given with the first sequence starting with 2, or rather 1. Then after 1, we have a 2. Then after 2, we have a what? We have a 4. Then after 4, we have a what? We have 8. After 8, we have 16. After 16, we have what? 32. After 32, we have 64. The question is, how do we get the next 3 terms? The most important thing is to find the formula which is used. How do we find the formula? Now, to find the formula, we need to find out how the first term is related to the second term. That is going to be the first step. Notice that onto the first term, 1 was added to get the second term. Now, let's put it there. Onto the first term, okay? Onto the first term, 1 was added. Now, to get the second term, all right, we already have the second term here, yes, which is the result of adding what? Which is the result of adding 1 to the first term. Now, let's look at the what? The third term, the term which comes after the second term. What's the third term? The third term is 4. Now, notice that from 2, which is the second term, a number was added. This time is 2. We are just testing because, we want to try with adding before we try with multiplication. Because we see the number is increasing. So either there is addition or there is multiplication. And so what do we get from here? Well, let's move to the next. The next number is 8. So now, from this next number, which is 8, we see that onto the previous number 4, a number was added. So, what's happening? Well, let's move to the next number, which is 16. Notice that to get 16 from the previous term, a number was added. Can you see something there? Well, what we see here is that 1, like here 1, 1, here 2, 2, here 3, 3, here 4, 4. Rather, 3, 3 is not there, but we have 4, 4, and 8, 8. What's that supposed to mean? It's supposed to mean these numbers are being doubled. There is the element of doubling, because when you see 1, 1, 2, 2, 4, 4, 8, 8, there is doubling. And so, what is being doubled? Well, when we double 1, we get 2. In other words, when we double 1, we get 2. When we double 2, that is, when we times 1 by 2, we get 2. When we times 2 by 2, we get 4. When we times 2, when we get 4 times 2, we get 8. 8 times 2 is 16. 16 times 2 is 32. Do you see that? Yes, the pattern is that of multiplying the previous term by 2. Okay? So, for sequence C, actually the formula is to multiply the previous term by what? By 2. So that would give us 1 times 2, okay, to get 2. Then 2 times 2 to get 4. Then 4 times 2 to get 8. Then 8 times 2 to get 16. Then 16 times 2 to get 32. And also, we could extend this to 32 times 2. 32 times 2 will give us the value of 64, which is what we have been given here. So the next thing is, what would be the next 3 terms after 64? Well, we have now seen the formula. The formula is that you have to double the previous term to get the next term. You have to keep doubling the current term to get the next term. You double the next term to get the next term. So from 64, we have times 2 to get, well, this will give us 128. I would like to check that first. 64 times 2, yes, 128. Then the next thing is 128 times 2. That is 128, okay. 128 times 2. That should give us a value of the next term. And what is that? Well, 128 times 2 will give us a value of 256. That is 256. And onto that, we can have 256 times 2. Okay, 256 times 2. What would that give us? Well, what would 256 times 2 give? Well, 256 times 2 would give us 512. So this is how we would find the next 3 terms. And after finding the next 3 terms, the thing we want to do is to rewrite the sequence given. So rewriting the sequence given would give us, well, after 64, we would be having 128. And after 128, we have 256. And after 256, we have 512. That is how we would generate the sequence. So now notice that the thing here is this. If it is required for you to determine the sequence, look for the first term, which is the first number in the sequence. Then see the next term. Should you see that there is an increase in the next term, or there is an increase in the term which comes after the second term, then notice there was addition. Now, the addition can also be investigated. If the same number is added, that means, if the same number is added, that means that is the formula. If it is not the same number which is added, then check with multiplication. Either there is doubling, or a number is first added, then a constant number now comes in, like the way we have seen in sequence A, sequence B, now sequence C. Now the next number is going to be sequence D, beyond which you will have a class activity. So now for sequence D, well, for sequence D, we have a 3, then a 5, then a 7, then a 9, then 11, then a 13, then a 15, then a 17, then a 19. Well, what are we going to do with this? Now, the first term is 3. The second term is 5. How did we get there? Well, something was possibly added onto 3. The next term is 7. How did we get there? Well, something was possibly added. Okay, something was possibly added onto a 5. Okay, and what is that? A 2. When you look at the next term, 9, you soon notice that something was added possibly on what? Onto a 7. And what is that? That is a 2. Now, even if you don't check the next term, you will still see that the pattern can be reproduced. So, to find 11, we take 9 and onto it, we add a 2. So, what's the pattern here? Well, the pattern is that you add 2 onto the previous number. What's that supposed to mean? You add 2 onto 11, you get 13. You add 2 onto 13, you get 15. You add 2 onto 15, you get 17. You add 2 onto 17, you get 19. That is how it works. Now, how do we get the next 3 terms? So to get the next 3 terms, we keep on adding, we keep on adding 2. Well, let's see how it comes. So, from the sequence that we have been given, just add a 2 onto 19 so that you get 21. Then just add a 2 onto 21 to get what? A 23. Then later, you will add what? You will add a 2 onto 23 to get a 25. Yes, these are the next 3 numbers. Now notice, you have to generate a formula. You have to check how the formula comes. If the formula has come really quick, then no, the solution is also going to come really quick. But check to be sure your formula is correct, at least with 3 to 4 numbers. And now when you are done with that, you get the class activity. The class activity takes from question 5 to question 8. Also in this class activity, you have to find the next 3 numbers in the sequence. And when you are done with that, just submit your work for marking. And from that, we will move on to the next. So until next time, we will continue with that.